We're looking at a single pot, single phase 25 kVA transformer. The service voltage for this transformer is 120 phase to ground, 240 phase to phase. It has an overhead service and an underground service. This is a single phase 3-wire customer. The first thing you do when you walk up onto a site is you look at the condition of the meter pan. You make sure that the meter pan itself is connected good to the building and the meter's sealed. So we're gonna go ahead and open the meter pan up. What I'm looking for when I walk into this, what I'm looking for when I get into this meter pan is to make sure the condition of all my lugs is good and that the pan is actually connected to the building. When you go to pull this meter, you don't want this all loose or any lugs loose, because then it could become a hazard where you're stuck standing right here holding the meter with the lugs that just broke off the back of it. That's why it's important to carry your cell phone with you, because we work most of the time by ourselves. So look at the condition of the lugs, view the overhaul condition of the pan, and then look to see what kind of load is on the meter. If the disc is going really slow, you're not going to pull an arc. But if the disc, the little line on the bottom, is moving quickly, you're going to pull a hard arc. Just a suggestion, if you ever come up on it and the meter pan has suspicion or suspicious looking, like it's not in perfect condition, as a rule, I always go put my face shield on. I think it's safer, and in case something happens, you're protected. Let's focus on the meter itself and the type of meter. This is a Focus AXR meter. It's a Form 2S, which means a 2S is for a single phase 120 240 service. It's a class 200. It means this meter is rated for up to 200 amps. It's a 240 volt meter. You need 240 volts to meter this site correctly. This is a 3-wire service, 2 hot legs and a neutral. 60 hertz system. Pico runs on 60 hertz. So do all American companies. The test amps is 30, and that's just what you test it at when you're testing the meter for calibration accuracy. And the case of 8 7.2 is for every 1 revolution. You see the little scrolling bar on the bottom right there, that little line? As load is going, it starts off here with 1 dot. And watch, as the load continues, you'll get a second one, and it can scroll all the way across. And when it comes back to this 1 dot over here, we have used 7.2 watts. So the case of 8 stands for 7.2 watts per revolution. The meter serial number is 168-274-431. Okay, we're going to go ahead and pull this meter. And I'll stand to the side. Now, let's do some voltage. We're going to do some voltage checks on this meter to show you the voltages that we get. And as you can see, this is the underground service that comes in, and it goes over to these bars on the top. So what we're going to do is we're going to take our leads and go to ground. This is the ground. And we're going to go top left lug. I get 123 volts. Top right, I get 123 volts. Bottom, nothing. Bottom, nothing. And let's go phase to phase. I should have 240 volts. 246 volts. So this is to be metered by a Form 2S meter. It's a 120, 240 volt service. Okay, we're gonna plug this meter back in. The voltage was good. We know it's a single phase 120, 240 service because I had the correct voltages. And go ahead, we're gonna plug this meter in. I wanna get the lugs. Come to the side, Ben. You can see the lugs, how I line them up in the center. And then as I come to the thing, I just bump it and tap it. Okay. Meter's in service. A good check. Another check that we have to make with these meters is we have a disconnect built into these meters. And before we leave this service, we always should make this check to make sure that the little breaker that closes the line to the load is closed properly, because sometimes those breakers don't make a good contact. So what I'm gonna do is I'm gonna go to ground. This is the load side of that breaker. So what I wanna see is 120 volts, which we see on the bottom left leg. And in the right leg, we got 122 volts. And then we're gonna go phase to phase, and we should have 240. Okay? So this is a good installation. I can go ahead and seal the meter pan up, and everything's good on this site. Seal the meter pan up, and take your old meter seal and put it in the garbage. This is a single pot transformer with 3 wires coming out of it. One hot leg, a hot leg, and a ground in the green. If we check voltage, we would go phase to ground, we would get 120 volts. Phase to ground, we get 120 volts. And phase to phase, we get 240. So this is a 120/240 volt service coming down the pole. We come up the meter pan. This is an HQ5 underground meter pan. You have 1, 2, 3, 4, and ability for a 5th lug right here that's not there right now. We don't need it for this service. Okay, so there's 3 service wires come up, and your hot leg goes to the line side, which is the top lug, and your other hot one goes to the right top lug, and your neutral is tied to the ground bus bar right here in the middle. And on the bottom 2 lugs, you have another hot leg going to the customer, and the ground. Okay, we're gonna focus right here on the single phase service vectors. We have a voltage A at 0 degrees and unity current A at 0 degrees. We have voltage B at 180 degrees and current B at unity 180 degrees. To meter this service, we use Blondell's theorem N-1 because we're using 1 potential coil to meter 2 wire service, 2 wires. So on this particular meter, we have a 240 volt coil with 2 current coils. So current A, since it's at 0 degrees, the current goes forward across the potential coil and comes out, and showing the polarity markers of plus and plus on the current coils. Now current B, we know current B is 180 degrees out. So what we have to do is we have to reverse that current through the coil and come in reverse flow, thus making it a positive and a positive, not a negative and a positive. If these 2 were just both forward through this coil, it would bucket and we would have 0 consumption completely. So we have to reverse current B 180 degrees and come through the coil in order to keep all my positives on the same time and meter watt hours correctly. If you look up here on the meter vectors, this is actually showing the meter form and what it's doing. We're using voltage A and B together at 240, and it's showing at 0 degrees. Then current A is already at unity at 0 degrees, so we didn't have to do anything to that. But this dotted line right here shows that I took this current and flipped it 180 degrees and put it on this same 0 degree path. So now the meter will meter it correctly. Okay guys, this is going to be very difficult to explain, but in a Form 2F meter, we use half of a current coil instead of a full current coil. And I used some calculations to show exactly why this pans out this way. Okay, with half the turns, we can take the 240 volts times half the current will come out with a half a turn and get 600 watts on B phase and get 600 watts, we'll get a total of 1200 watts. Now if we use the full current coil, the formula would be 240, I'd get 5 amps out of each full coil. So I'd be 1200, 240 times 5 is 1200, I would get 2400 watts. So to prove that why we are using half the turns, I'm gonna go to a perfect scenario in perfect metering where we use 1 full current coil and 1 voltage coil per phase. And when we do that, we're using phase to ground, so we get 120 volts for A times 5 with 600 watts, and 120 times 5 with 600 watts, we get 1200 watts. And the reason we're splitting this current coil in half is because we're using 240 volts. Well, you and I know that each phase to ground should be only 120 volts to measure times current for an imbalance. So to justify using one coil, we have to take the current coil and split it in half. I think back in the day, the reason they used this one coil method was because metal was scarce. It was during the war and all. Instead of using 2 coils to ground, they used one coil because it saved money, and it was during the wartime. They needed metal and all. So I think that's why they went to this theory, and once it's been out there, it's been used nationwide, and it's kind of hard to turn back once we've started this method of metering.